Dear students, today we will learn trigonometric identities. Trigonometric identities are the identities or the formulas that are trigonometric equations valid for each and every value of theta lying between 0 to 90 degrees. For example, we have first identity as sine square theta plus cos square theta is equal to 1. There are three main trigonometric identities. The second identity is secant square theta minus tan square theta is equal to 1. And the third trigonometric identity is cosec square theta minus cot square theta is equal to 1. To remember these identities, I will give you a trick. This one is a very fundamental identity. Here we have plus sign. So it doesn't matter whether you write cos square theta first or sine square theta first. In both the way, it is remain the same. That is sine square theta plus cos square theta is equal to 1. But if the order is reversed, then this identity will be wrong. Same way, since there is a negative sign in between, therefore this identity will be wrong if you reverse the order. To remember this, in which order they will exist in this identity, you will always remember this letter S is very powerful. And secant square theta has S in it, so we will subtract tan square theta from secant square theta and we will get 1. Now observe these two trigonometric ratio. Cosec contains S. So this identity will be cosec square theta minus cot square theta. Children, if you remember these identities, this can be written in this form also. So from here only we can get that they can be learned in two ways, two forms. The one is sine square theta is equal to 1 minus cos square theta, or cos square theta is equal to 1 minus sine square theta. So this is the same identity, but the results can be learned in this form also. Similarly, if you have this identity, the result can be written in these two formats that are first secant square theta. As I told you, you will always consider the trigonometric ratio which has S in it as the powerful one. Therefore, secant square theta will be equal to tan square theta if you add 1 to it. And similarly, if you want to get the value of tan square theta, to remember it, you will again say that secant square theta is powerful. Therefore, 1 should be subtracted from it so that the two becomes equal. So secant square theta is powerful. Therefore, 1 should be added to tan square theta. Tan square theta is less powerful. Therefore, 1 should be subtracted from secant square theta so that both should be equal to 1. And then to remember this one, again, we can have two more identities. Again, if you want to write cosec square theta, since it has s in it, therefore cot square theta plus 1 will give you cosec square theta. Similarly, cot square theta is less powerful as it is not having s in it. So 1 should be subtracted from cosec square theta so that it should become equal to cot theta. This way we remember all these identities. So there are three main identities, and out of these three identities we'll get two more. So in total 3 and 6, there are total 9 identities to remember. And now children, let's see how we can say that sine square theta plus cos square theta is equal to 1. To prove this, let's start from left hand side. Sine square theta, you know, is equal to perpendicular upon hypotenuse. Since I want to write the square of it, so I'll square. And cos square theta is base upon height and its square. So when you open the bracket, it will be perpendicular square upon hypotenuse square, and then this will be base square upon hypotenuse square. Let's take LCM. So this will become hypotenuse square and perpendicular square plus base square. Now children listen, perpendicular square plus base square by Pythagoras theorem. Remember Pythagoras theorem, hypotenuse square is equal to perpendicular square plus base square by Pythagoras theorem. So this can be replaced, perpendicular square plus base square can be replaced by hypotenuse square, and hypotenuse square and hypotenuse square will cancel each other and you will get 1. So this way we can say that sine square theta plus cos square theta is always equal to 1. Now let's prove one more identity, that is secant square theta minus tan square theta is equal to minus tan square theta is equal to 1. To prove this, children, again we will take LHS. So let's start from LHS. LHS is secant square theta minus tan square theta. Therefore, secant square theta, you all know, is reciprocal of the cos. So here I can write 1 upon cos square theta. And tan theta, you all know, is equal to sine theta upon cos theta. And since we have square here, tan square theta, therefore this will become sine square theta upon cos square theta. And when you take LCM, this will become cos square theta, and this will become 1 minus sine square theta. Children, as we have just now proved this identity, so from this identity only, 1 minus sine square theta is equal to cos square theta. So 1 minus sine square theta is equal to cos square theta. Therefore, this can be replaced by cos square theta, and denominator is again cos square theta. Therefore, they will cancel each other and you will get 1, which is equal to RHS. Similarly, try yourself to prove that cosec square theta minus cot square theta is equal to 1. Prove it yourself. This manner I have proved secant square theta minus tan square theta is equal to 1. Same way you are able to prove this one. So these are the important identities that you will be using to solve the questions of exercise 8.4. This is the very important identity. And let us begin with question number 1 of exercise 8.4. So this is question number 1, and in this we have to express all the trigonometric ratios in terms of cot A. Express all trigonometric ratios in terms of cot A. That means, children, let's understand the meaning of this question so that we are able to attempt it. Express all trigonometric ratios in terms of cot A means you need to express all the trigonometric ratios in terms of cot A. That means we need to find out the relation between sine A and cot A. So that means sine A is equal to how many cot A? That relation we need to find out. That means this side it will be sine A, and on the other hand side we should have cot A plus something or minus something. There should be some relation between sine A and how sine A is related to cot A. Basically you want to find out that. So if you want to express sine A in terms of cot A, so if you are deciding that first of all you will find out the relation between sine A and cot A, among all these three trigonometric identities, you will decide yourself which can be converted into sine. So children, you know that this is cot that we need, and we need sine. So cosec is the reciprocal of sine, which can easily be converted into sine. So I will select this one. I will start from here and will find a relation between sine and cot. So to begin with, I'll write down this identity and start with it. So this is cosec square theta minus cot square theta is equal to 1. This side I will leave only sine, and the other side I will take cot. So I will take this cot that side and will convert cosec into sine because I want to get the relation between sine and cot. So I'll be writing this as 1 upon sine square theta is equal to 1 plus cot square theta. Or I may write that 1 upon 1 plus cot square theta is equal to sine square theta. And I want the relation between sine theta and cot theta. So children, I will remove this square and will write sine A is equal to under the root 1 upon 1 plus cot square theta, or further simplifying, I may write that sine A is equal to 1 upon under the root 1 plus cot square A. Children, you must be thinking that I have removed square, so there should be a sign of plus and minus both. But since between 0 to 90 degree, all the trigonometric ratios have positive value only. Therefore, I will not consider the negative sign here. Similarly, you will find the relation between cos and cot. So if you want to find the relation between cos and cot, again you will select one among these three so that you can easily be able to get it. So then sec square A can be converted into cos and tan square A can be converted into cot. So I will select this one. We'll start from here. Secant square theta minus tan square theta is equal to what? I want the relation between cos and cot. So I will leave this side secant square theta only and take this tan theta that side. Now I will convert sec into cos because I want the relation between cos and cot. So I will change this as 1 upon cos square theta. Similarly, I will replace this tan theta by its reciprocal cot square theta and then take LCM. So this will become cot square theta, cot square theta plus 1, and this is 1 upon cos square theta. Take reciprocal both the sides. So this is cos square theta is equal to cot square theta upon 1 plus cot square theta. Therefore, this is cos theta equal to under the root cot square theta upon 1 plus cot square theta. On further simplification, you will get cos theta is equal to cot theta upon under the root 1 plus cot square theta. Similarly, you are able to get the relation between all the trigonometric ratios and cot theta. So try them yourself. Now see, in this question, you need to evaluate this thing. So if you want to evaluate, just see this is a mixture of complementary angle as well as identities. Here you will apply both the formulas. So children, see this angle 63 degree and 27 degrees. These angles are complementary angle. And here again 17 degree and 73 degree, they are complementary angles. So whenever we are solving the questions related to complementary angle, we change one among the complementaries. So that means out of these two, you will be changing either this or this. So let us decide that we will change the first one. So sine square theta, I'll assume 63 as theta, sine square theta. Now apply the formula sine theta is equal to cos 90 minus theta. So if it is sine theta, you will convert it into cos 90 minus theta. So this will become cos 90 minus 63 degree. And since it has a square, so we have to put this square here also. And among the two numbers, two trigonometric ratios, we will be changing this one only. Similarly, in the denominator, we will change one only because these are the complementary angle attached to it. So cos theta the identity for that is cos theta is equal to sine 90 minus theta. So if you change it in this, that means you will be writing sine 90 minus 17 degree as cos theta. You are assuming 17 as theta. Cos theta will be equal to sine 90 minus theta. So in place of theta, you will be writing the same angle which you have assumed as theta. And since it is a square here, so you will put a square also. Then plus cos square 73 degree. So I told you in the last video that in complementary case, we first apply the formula, then we only subtract. So this will become cos square. When you subtract 63 from 90, it will become 27 degree plus sine square 27 degree. And in the denominator, sine 90 minus 17 you will subtract and will get sine square 73 degree plus cos square 73 degrees. Now consider 27 as theta and read these two. Cos square theta plus sine square theta. And you know that cos square theta plus sine square theta is equal to 1. So this will become 1. And similarly in the denominator, sine square theta plus cos square theta again 1. And therefore the answer to this is